All right, I'm going to give this a try. I have 3 or 4 other times tried to post videos and it didn't work. So let's see if this goes. I'm hopeful that it will. All right, so we're in the eukaryotes, and I put up a lecture already about this. I think that one worked, but I do want to review a little bit, and so just to kind of go back over this endosymbiosis theory. Let me pull a new slide up here. Yeah, I'll go ahead and review some things relating to that. So remember, one of the chief proponents of this idea, the endosymbiosis theory, well, for here on out, we'll call it the EST. That was spearheaded by Lynn Margulis, and there were a bunch of other folks, so at all means and others. She was like the main name that was, really central to all of this development of this. About 50 years ago, late 60s, early 70s. And the first event was the development of a eukaryotic cell from a prokaryote. And so here's a prokaryotic cell. There's its nucleoid, which remember is just a little circle of DNA. Protect that better, what's thought happened was some of them developed this invagination of their membrane that then came to surround that nucleoid. So the next step in the development of a eukaryote would have been something like this. Oh, that's horrible. Sorry. An invagination of the membrane to the point where it came then to surround nucleoid. So here's our nucleoid, and these two little loops of membrane are coming in and pushing around that. And ultimately, they would come completely together, and there'd be sealing of the membrane here as well. So you'd wind up with a nucleoid now that is wrapped in not just one membrane, right, but a second one as well. If membranes invaginated as is shown in that picture. So this now would be, this pair of membranes is now a nuclear envelope. And the advantage is probably that, the DNA is better protected and that cell stands a better chance of surviving. And then from there, a cell like this could, obtain enough energy, would start to swallow up other organisms, other prokaryotes. And so doing that would require, or would entail, pretty much the same sort of deal, invagination of the membrane around this. And ultimately, when that is complete, you'd wind up with a cell that not only has a nucleus with a nuclear envelope, but a phagocytized prokaryote that, if it doesn't get digested, if this guy continues to persist and metabolize, it could give abilities to the host cell that it wouldn't have had otherwise. And so note that this endosymbiont, if it continues to live within that host, would be called an endosymbiont. It's got its own DNA in a nucleoid, right? And it's got two membranes as well. All right. And so those are all things that we wouldn't predict if the evolution of eukaryotes hadn't taken place in this fashion, involving endosymbiosis. So nowadays we have at least two kinds of organelles that conform to the predictions of this model. Mitochondria are like that. They've got two membranes and they've got their own genetic material, and chloroplasts as well. So, yeah, it all just seems to make a lot of sense, and it's very difficult to envision things having happened in any other way. So that's kind of my review of the endosymbiosis theory. So you can review that, and that might be a good essay question. So let me stop this lecture here to make sure that it posted, and then I'll continue on with more about eukaryotes and go from there.